And the example app is written for Android. We'll also talk about like how is this the same in the world of iPhone, and as well as how is this different in the world of iPhone and some of the differences between the two platforms. And so, like with smartphones, there's a lot of focus on the device and the platform security. And if you probably guys remember from a year and a half or so ago at RSA, where some folks found if I send malformed text messages to iPhones, I can root the phone. So there's a lot of focus on that from a media standpoint, which is important because if I can find a way at a platform level to remotely root the phone, that's obviously really bad. And as an attacker, that gives me broad latitude and a huge population of folks that I want to attack. But most of the organizations that we talk to are kind of have accepted the risk. They've said, like, we know that our customers are going to be using iPhone. We know that our customers are going to be using Android phones, and we've got a business case that says we need to provide them with an application. And so the security of the platform is something that's that you're not making a go no go decision on. It's the decision's typically made. We've got to come out with an app for this platform. And so the focus is more on the the security of their customers. What risks are they opening their customers up to if their customers are using these applications, as well as what sort of risk are they opening themselves up to by putting out the app and the infrastructure to support that application. Who here has, your organization has a smartphone that you've deployed for customers? A couple folks, yeah, a pretty good population of folks. Is it iPhone or Android or other? All the above, iPhone, Android, Web OS, anyone? No? Excellent. Who here's had found out secondhand that they had smartphone applications deployed for their organization? Anybody? I was on a phone call with a customer last week, and he said, "Hey, you come to AppSec? We're going to presentation on this stuff." I was like, "Oh yeah, I'm interested. We're probably going to be doing something in the mobile space in a while, and I'm interested in kind of getting in front of that." And we Googled around and looked for their company name and Android, and it turns out they'd released an Android application 2 weeks before, and the security group didn't know about it, right? And so the application got built by the marketing group went out and hired some dudes in Romania or some offshore development shop to build this app, and it had been pushed out to their customers, for 2 weeks, and this guy didn't even know about it. And so that's we see that a lot. It's kind of similar to SharePoint deployments and stuff like that, where a lot of times right now these apps are not being run necessarily through your normal dev group. They're being installed or procured by the marketing department or some other group. And so that's that. Additionally, even if you've got a really strong SDL, if the security group doesn't know about this and can't check it, then your SDL is really kind of for naught. So for just a real generic threat model, looking at this application, you've got the smartphone user. Who's using a smartphone application. You probably have some sort of persistent storage on the device, and then the application is probably going out and again, an interesting application is probably going out and potentially talking to third-party services you don't have control over, as well as talking back into your organization to some sort of services that are providing your organization's data. And so from a trust standpoint, you don't necessarily trust what the user is doing to your application, but you also certainly don't trust what other people might be doing trying to come in through these different network resources. And if I'm a process running on the smartphone, I don't necessarily trust the stuff coming from these third-party services that aren't controlled by my organization. And so it's a little bit more complicated environment that you've got to look at. And so, for the developers, who here is a software developer? All right, excellent, good. Doing actual development, you're an actual developer. Dennis Cruz will come around and give each of you individually a hug. If you're I think that's what he promised this morning. No, so that's good. So, for developers, like it's important for developers to understand the implications of the stuff that they're doing, because you know, if hopefully you've got developers and they're looking at web apps a little bit differently these days. Well, it's the same thing for you know, for smartphones, and smartphone applications are essentially thick client applications, all right? Except for that people carry them around in their pockets, they drop them in toilets, they you know, put the applications on eBay when a cool new iPhone comes out, you know, leave them on airplanes and so on and so forth. And so one of the like nice things about developing in a web environment is you get to hold all the code on the server side, well, until you start Ajaxing stuff back. But like, you know, the code is on the server side doing all this stuff, and that provides you with a little bit of opacity for folks that are trying to misuse the application. But in a smartphone world, you have to assume that the attacker is going to be able to access the target user, like victim devices, you know, and you got to assume that they're going to be able to get your application, you know, binaries. And so, a really important thing that we, you know, that we recommend when we work with people is for the developers to understand, like, hey, let's assume that all this information is available. So you have to build your application defensively, assuming that this is all going to be available and compromised. So I've got a real simple sample application here, and the funny story about the sample application is we do all these presentations internally, like lunch and learn style, so that folks in the office can like look at them and ask questions and stuff. And I was going through a draft of this, and one of my guys raised his hand and said, "Are you going to use, like, those are all examples from like client engagements? Are you going to use those in your presentation?" And I said, "Oh, of course not. I'm going to write a sample application." And so we've got just a real simple sample application where you attach to your brokerage account. You can pull stock quotes and make stock purchases, or so make stock purchases. And again, it's intentionally nasty, but it's. I guess my question for y'all is it unrealistic? You know, all the problems that we're looking at are things that we've seen in looking at actual applications out in the wild, both you know, that we've, you know, for clients that we're assessing stuff for, or just, you know, with us going out and doing research and looking at stuff. And my apologies to anyone who has any sort of eye for design. There we go. But so with the application, let's get a stock ticker symbol from someone. Anyone? What do you like? AAPL. Let me switch to the. All right, so we got AAPL. Well, first we can go in and we enter our, you know, attached to the account, right? Apple, go get the quote, you know, 263. How many shares do we want to buy? 1,000? Great. All right. Buy, and we go down here and we look in my nice little attractive thing down there. We can see all the stuff that it's doing. And so again, pretty basic application, but it's doing a couple of interesting things. We're going out and we're talking to some sort of a third-party service to pull stock quotes, and we're pulling that information back. We're attaching the account, or we're attaching this instance of the application on the smartphone to you know, to an account via an account ID, and then we're doing stuff and presumably making some sort of transaction that's valuable with the you know, with the purchase. And so pretty basic stuff that you see for smartphone apps. So, you know, what's a bad guy going to do in this case? And we'll look at this for an Android app and talk about how iPhone might be different later. But you know, they're going to install. You know, you got to assume that they've got an Android phone. They're going to install the app on the device. They're going to root their phone. They're going to pull the application APK file off, and they're going to take a look at it. And so, what sort of stuff can they see? And we'll step through this manually. I've got like a nasty Perl script that does this, and so I'll stuff that up on the web if folks want to try this on their own try this on their own apps. But you know, to automate what type of information is somebody going to be able to automatically extract? And so, big secret: APK files are zip files. All right. You heard it here first, and they contain some XML files and DEX binary code, and kind of the important, or the starting point file is the Android manifest.xml file. So if we look at this, these are all okay. So if we look in this here, the Android manifest file, the Android XML file, manifest XML file, it's a real nasty, goofy binary format. So that's not super attractive, but there's freely available tools out on the web. There's one AXML to XML. It's a Perl script that'll actually go through that and turn that into text. So when we see the actual unpacked file, and again, this is a pretty simple app. It's just got two different screens, but those screens are listed in there in the application. It's got the activity for home. It's got an activity for config, so it's two different screens. And then down below, we can see the stuff, the use permission, and so those are the permissions that the application is going to request. So when you install the app on the phone, that's going to that's going to let folks know if what the application needs to have access to in order to work. And so you hear, if anybody followed the news where this this big rigmarole about this is a wallpaper app and it requires all these permissions in order to run. Those are the permissions there that they're talking about. And so as a bad guy, that's going to let me know these are the, once this app is installed on the device, these are the permissions that, these are the facilities that I might have the ability to go in and misuse. And so we can do the same thing with the other XML files, and so you can recurse, and all the UI layout stuff in Android is all done in XML files that then get during the build process get rolled up into this r.java. And so if you do want to do if you're using static analysis tools as a developer, you've got to basically run through the first half of the build process so that r.java file gets created, and then you need to include that r.java file when you do your when you stuff everything in to go and do the build. If you're coming at it from the other side. Okay, and so what about the code? There's a file in there called classes.dex, and what Android phones do, all the Android apps, are written in Java, or most Android apps are written in Java. Android's a Linux-based thing, so you can also write things out in C libraries and whatnot. But for the unless you have some real-world super performance stuff that you need to do, the code is all going to be written in Java. But rather than running a standard Java virtual machine, Androids run this Javlik virtual machine, and so it uses DEX code rather than Java bytecodes. And the DEX virtual machine is very similar to a Java virtual machine, but it's a register-based virtual machine versus the Java VM, which is a stack-based virtual machine. And so to queue up a method call, you put things in registers and then make the call, versus in in a Java environment, you push a bunch of stuff on the stack and then make the call. And but much like Java, where a tremendous amount of debug and other information is included when you compile the stuff out, DEX code also contains a tremendous amount of that. And so it's a pretty straightforward, pretty easy process to take all that DEX byte code and reverse it back into DEX assembly code. And the nice thing about DEX assembly code is it's fairly easy to parse using stuff like grep. You can also, and we'll look at this, you can also take the DEX code, turn that into a Java class, which then, or into a jar file, which you can then decompile back into Java. And so you kind of get that process is less deterministic. And so so we've seen on all the times we try to back that stuff out, there's parts of the Java that you can't regenerate. And so when we're looking at these apps, we're looking both at the DEX assembly code, which is easy to parse in a fairly unsophisticated way, running some greps and stuff like that to target things, and then you can actually look at the reversed Java code if you want to get into more detail. So yeah, let's pull up a version here. All right, so that's the DEX file again with the DEX stuff at the top. Not super interesting. But when you run it through this ddexer, what you see here is we now have, we unpack it into classes DEX unpacked, and it's got the same Java-style package structure. And so you see up at the top there, it basically declares it a class. What the superclass is, you can go and find the member, the member fields that it's got, and then you can go in and find the different methods. And so here's the here's the constructor, no-arg constructor, where it calls the its superclass. We've got a private method here, attach account. And it's pretty easy. I mean, it's not as nice as looking at Java code on its own, but it's pretty easy to follow the flow of what the application's doing as you step through different things. And so you can see as you create variables and initialize them. And you start we build a string there, and down here